Hello everyone, I am Indrajyoti Gaine. I am a PhD student at Department of Mathematics and Statistics IIT Kanpur. Presently, I am a PMRF fellow. Before that, I was a CSIR fellow. I have cleared my CSIR net with 108 rank. So today, we are going to discuss about three-dimensional geometry, and this is an introduction chapter we will learn in class 11, and after that, in class 12, we will learn this topic in further detail. So first of all, let's understand then why this three-dimensional geometry is important. Let us suppose that you are located in some now. If you are located at some point, or you are standing at some point, and at that time your friend call you that where you are, then asking you that where you are. How you can locate yourself? Like you are in the ground. So if suppose that there is a tree nearby you, or there is a post office nearby you, like there is something nearby you which is well known. So you will address yourself that I am beside the post office, or I am beside the school, or I am beside the tea stall of something tea stall, and you will say to your friend that I am here. So this location where you are located, that is very much important. Now, this is you can manage somehow by objecting some other thing, but how you can mathematically identify or mathematically locate a point in our reality, like because in our reality everything is in three dimensional, right? So in three dimensional you need to locate something. So how you can locate? So that's why this three dimensional geometry comes into the picture. Suppose let us take an example. A bulb is hanging in between the room, okay, from the ceiling. Now, what is the location of the lower tip of the bulb? How you can locate this? So for that, what you minimum require, that where it is located. So how you can locate that point? So first, we we must say that how what is the height of the bulb? What is the height of the bulb? And from where we measure the height? From ground. Okay. Now next, what we will measure, that how much distance this bulb is hanging from the walls, right? From the walls, how much distance away this bulb is hanging? This is the next question. So in this case, we need the three-dimensional geometry. So before going to that, we know about the plane. So in the plane, suppose this is our xy plane, and obviously this uh, skin of the tab is also a plane. So obviously, if I draw like this in color, suppose this is our plane, and these two are perpendicular lines representing the axis. Axis means this is x direction and this is y direction. So accordingly, this is minus y direction denoted by y dash, and this is negative x direction denoted by x dash. And where these two perpendicular lines meet, this is called the origin. Now, in reality, it may happen that where is the origin located? You don't know about that. But for that, you just assume that okay, this is the origin, and from where I want to measure everything. Okay, this is perspective, like this is relative. This is not absolute that you need to fix the 000 point at that 0 point or origin at a particular point. This is up to your hand that where you want to fix the point, and accordingly you can measure everything in the room or in the world with respect to that origin, but passing to the passing by axis. Okay, so in the plane, suppose this is x-axis and y-axis, and they meet at the point O, that is origin. Now, if there is a point, suppose here P is a point. So how you can find the distance of this P from this origin O, or how you can approach this? One way is like simply going from origin to directly this point. This is one thing, and this is representing the distance between the line O and P. This is the shortest distance and say actual. But if this is the thing, then this may happen that for this point also, this is also one line. This is representing the distance. So this is a little bit hectic to identify the location of the point. So it may happen that this point also has location like this. Similarly, if I say that a point is located here, a point is located here, and you have a line from this end to this, right? Now, even though this is not clearly visible, but you can at least understand that if both the points are P, then this OP and OP dash are same. The length of OP and length of OP dash are same. So if I say that this P point is OP distance from the origin, then the next question comes at which direction, at where, at which place. It is in this, it is here, here, or here. This will be the next question. That's why we use the coordinates. Coordinates help us to understand the point, location of the point by just their representation way. How we present that coordinate? So at first we walk along this x-axis up to this. Then we walk along this y-axis like this, and we reach the point P. So here we have traveled positive x dash, or say x1, and we have traveled positive y1. So the location of the point P or coordinate of the point P in the plane will be 1 comma y. Okay. Similarly, if I select a point P here, P dash here. So here also you walk x direction, x1 distance from x along x direction, but y1 direction in the negative y dash negative y direction. Y1 length in the negative y direction. In first case, this was like this and this. In second case, this is like this, but this. So this is length is y1, but the direction is in negative axis. So the location of the point will be x1 comma minus y1. Okay. So by this representation, we know that the point relies in which coordinate or which section of this fourth, section, in which section it will be like. Okay. Now come to the 3D. So whenever we are talking about the uh, bulb tip, then what we need? We need the location of the bulb tip from the ground. That is at ground. If I drop the bulb tip, or if I drop the bulb at ground, where this bulb will touch that point time, and also together with we need the height. For that, what we mainly need k axis. Okay. So suppose we have shape plane. So now we go subsection. The section is coordinate axis and coordinate planes in three dimensions. Coordinate planes in 8 dimensions. Okay. So how you can see this? So suppose we have three planes. Where how it is how it will look like. So suppose first plane is like looking like this. That's more different color. These all are in 3D. So just try to imagine this picture in 3D. So this is a plane. Suppose this is a plane, and this black side. Suppose this black side is in the front, and this red side is in the black. And we can see this surface. You can see this surface like this. Just think about it is 3D. It is not a 2D picture. It is 3D. This black is in the front, red is in the back, and we can see this surface. Or we can't see the opposite surface. Like whatever in here, like opposite of this plane, We can't like this. We are thinking like this. Okay. 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 Now this is one plane. Now draw the next plane. Next plane, let's say use the different color. So this is the next plane. Now the dotted section, what it presents? The dotted section represent that is we can't see. But that is present there. That line is present there, or you could say the plane is present there, but we can't see. That's why I have drawn that by dotted. We that is we are in the plane, we can't see that. Actually, the figure look like will this, but for our understanding purpose, we are just drawing the dotted points like this. That is they are present, but we can't see that. And another plane will be like this. So this is another. So here you can see this is a 3D picture. This plane is parallel to some line, like you can say like a float. Now these three planes intersect each other. So one intersection will be like this. Let's use some red color to be better. One intersection will be this black line and blue line intersect like this, intersect like this. Okay. The green line and the blue line intersect like the green plane and the blue plane intersect like this, right? And the which one is left? The black line, a black plane, and the green plane intersect like this. Okay. Now extend this line further. So I am drawing the extension by yellow color. So extending this line, nothing else. I am extending these lines. Okay. Now, if I represent this point as O, this point as O, and now I can rub all those things, but I'm not rubbing just for understanding purpose. So this is the three perpendicular planes. If I did three perpendicular planes intersect each other, then this intersection lines I will get, and this figure I will get. Now, clearly you can see that this point is O. Now this line, this this line, this is like X, X plus. Not it by like this. This line, denoted by Y, Y dash, and this line denoted by Z, Z. Okay. Now, if I keep this picture as it is and draw the axis again, so ultimately we get like this, something like this. This one, and this one. So let's represent something different here, so it will be better to understand. So let's denote it by x, this one by x, this one by x dash. Okay. this one by y, and this one by y dash. Little bit. So just yellow lines are drawn by blue line. So accordingly, the axis will be like x, z, y. I'm writing this negative axis by y dash, z dash, and x. Okay? So thus we obtain the axis, and using this here, this O will be the origin. O will be the origin, and using this the axis, it I can point out. I can look at any point in three-dimensional position. Now this OX x dash, this line is denoting the x axis. So this x o x dash is the denoting the x axis. This y o y dash denoting the y axis, and z o z dash is denoting the z axis. Okay. Now this, let us represent the black lines. These black lines are representing the positive direction, and these blue lines representing the negative direction. Similarly, this black line OY representing the positive axis, like the positive y direction, and OY is representing the negative y direction. As same as this, as same as the case for 2D, we have learned. Same will be applied in 3D. Similarly, this OZ will be representing the positive z axis, and the OZ dash will represent the negative z axis. Now, depending upon this sign, one can divide this 3D space in 8 octane. That's why it is called octane. First octane, second octane, third octane, fourth octane, fifth octane, sixth octane, seventh octane, eighth octane. Before proceeding to the case of octane, let us understand the planes. Plane means some XYZ plane, XY plane, YZ plane. So how we can represent these coordinate planes? We are know about the coordinate axis right now. We just have learned this coordinate axis term. Now, what about the coordinate planes? Right? So, what is the coordinate plane here? Clearly, you can see from here. If I draw this thing like this, and if I say that this is a plane, so this plane is in the line like Y O Z. So the plane, the surface Y O Z is called YZ plane. And this is not only this plane, it may happen that this plane is like here only, here also, or this plane is like here also. Like this plane, this green line, the plane drawn in by green color is the YZ plane. That plane is called the YZ plane. Similarly, the black color plane, that is representing our XY plane. Okay, because in that plane you can have two coordinates, because every plane is a 2D geometrical perspective. So whenever we want to locate something in that plane only, not in 3D, in that plane only, then two axes is sufficient, two coordinates is sufficient. That's why we are using these planes. We are representing these coordinate planes, and here you can see the why this y8 and why this yz with, because we are working in 3D. Now in 3D we can put three perpendicular planes. Now all planes are, we can't explain this by x and y, because for green plane we can use x and y, y and x and y, and also we are using black, for black plane x and y, also for blue plane x and y. Then we can't understand that this point is on the XY plane or a YZ plane or which plane. Like that point is on the green plane or black plane or blue plane. We can't identify that specific. That's why we are using different locations like XY plane, YZ plane, or XZ plane. Okay. And which one is denoting by this? That in that plane, which axes are coordinate axes are lying. In that plane, which coordinate axes are lying. Depending on that, we are representing that plane by that plane. Like why if the plane has x axis and y axis, then that is called xy. If the plane has y axis and z axis, then that is called the yz. Similarly, we get xz. Okay, these are called the coordinate plane. Now, why we need this coordinate? So suppose we need to find out a point. So to find out the location of a point, we must need the help of this coordinate planes. Otherwise, it will be difficult to understand that how we can approach that point from from origin, or you can say from another point. We need the help of this coordinate planes. That's why we need this coordinate planes. Okay. Now, these coordinate planes, this you can see from the geometry of this figure. This figure, you can see that these coordinate planes dividing the whole 3D space into 8 portions. Okay, first of 10, second of 10, third of 10, fourth of 10, fifth, sixth, seventh, eighth. What is the first of 10? So the first of 10 is like I am just drawing the figures small by small, that will it will understand, that you can understand properly. So the first of 10 you can just watch this and understand from the 3D perspective here. The first of 10 will be like this. This one. So here it is the origin. I am not drawing the other coordinates because of the understanding purpose. So just compare these figures with this one so that you can understand that which or about which I am talking about. So this is like x, y, z. Now x, y, z means these are all positive axes. So in this coordinate, any point will have coefficient plus, plus, plus. Means coefficient means the sign of the coordinates. All are positive. That means that point lying in the first octane. Okay. Now second octane. Second octane means this x prime, y, z. So here what is the point? That is x is negative, but other two are positive. So minus, plus, plus. So from the figure you can see that we have the first octane was here. The second octane is here. Okay. Just like compare these two figures, then you can clearly understand. Okay. Now what about third quad? The third quadrant will be this x, this y, and this z. So z, that is o, h dash, y. It is represented by minus, minus, plus. What about the fourth case? The fourth case will be right z, o, x, y dash, and what will be the sign of the coordinates? That will be plus, minus. Now just before proceeding to the fifth, sixth, seventh, and eighth case, just try to understand that these four figures, like this first one, second one, third one, fourth one, these four cases, Z is positive. Okay? So by this, we have represented this whenever the Z is positive. first one, second one, third one, fourth one. Okay. When the Z is positive, like we are on the positive Z, like height is positive. Now we will go to case where the Z is negative. So what is the fifth case? Fifth case will be Y positive, Z negative. Z test O Y X. Compare this with this. Which one? This one. Right? So this point will be located like X, Y, Z. Because X positive, Y positive, but Z negative. Okay. Just depending upon these things. Like OX is positive, O X dash is negative, OY is positive, OY dash is negative, OZ is positive, and OZ dash is negative. Like this. Like this, we are doing all this. Now, whatever the sixth one, we are going to the same thing like just this figure with Z negative. With Z negative. So, what will be the point? X, Y, X dash by Z. This point has this coordinate has the coefficient like minus, plus, minus. This X dash, this Y dash, this Z dash, Z dash, and this point is represented by negative, negative, negative. That is all are negative. And the last one, this will be like this. X, sorry, this X axis, Z dash, Z dash, Y dash. It is plus, minus. So by the last four, that is 5, 6, 7, 8, we have covered the lower portion. Thus, we can divide this whole 3D space in 8 octane. Now, if I give a coordinate of the point, how we can find the coordinate that I will come later. But if I give a coordinate of the point, depending upon the sign of the coordinate points, we can clearly say that this point lying in the first octane, second octane, third octane, fourth octane, or any other octane. In which octane that is lying, we can clearly understand from the sign of the coordinate point. Now the next point comes that okay, sign is clear, but how we can denote that only sign just can say that it is in the which quadrant. Now the next thing comes that at which point it is present or what is the exact location of that point. So for that, suppose we are in the first quadrant. Suppose I'm not saying that it will always be in first octane, but just for understanding, let's say that we are in first quadrant. Okay. So for that, see our suppose this is our X, see our Y, and see our Z. Okay. Or for understanding purpose, you can use some different notation, but okay, this one is fine. Now you suppose you have a point P at this point. You have a point P. Now how you can approach this point? How you can approach this point? So for that, first what you need? You need to come or you need to drop a projection of this point in the xy plane. Okay. How you can drop? Suppose this is the projection of this. Suppose this is the projection of this point PM. Okay. Now from 2D perspective, it may or may not be looking clearly. It may happen that you are getting confused. So just try to understand this thing that we are working in 3D. So it is nothing like that if I have a point P here, then P can be a projection on the x-axis directly. Not like that. Not like that. Because we are working in 3D. So it may happen that this P is moving at anywhere. It may happen that its position is on the x-axis, its position on the y-axis. It may happen. It can be the case. Like it may happen that this P has projection like this only, or this P has projection like this only on the x-axis only. But we are working in steady, so it may happen that it is projection on the x-axis, but it may happen that it is not projected on the x-axis. It it can have projection on the xy plane anywhere, or it may have projection on the yz plane that will come later. But first understand if the projection is on the xy plane. Suppose this is the point P and it has projection. The projection means if I drop the point from along that, where it will drop. Like if I drop the bulb from the ceiling, what point it will touch first. Similar thing is here. So suppose this is the first what is the position we have. Now I need to find the location of this point. We have know about this height. This is the height of the point P, or you can say the distance covered along the positive z axis. Now next step is where this M point is located in the xy plane. So for that we can use the well-known Fourier geometry, right? So for that we will walk along this x-axis, along this x-axis, then we will walk along this y-axis. So we can reach this point. So what is the way to reach this point P? This way. And suppose this distance is x distance covered by this distance is y1 distance covered by, and this distance is z1 distance covered by z1 distance covered by. So the location of the point, or you can say the coordinate of the point P will be x1, comma y1, comma z1. So this will be the coordinate of the point P. Okay. So similarly, for understanding purpose, let us do another example. Suppose this is our x dash, y, this is z. Okay. Now a point P is lying here. Point P is lying here. Okay. Now how I can locate this point P? For that, at first draw the point position on the plane. Position on the plane means xy plane. Suppose here this plane is xy plane. Now we will move along the xy plane and we will find the distance from this position point. That is, we can say it is M. Now we can find the location of this point M. So along X we have to suppose walk X1 distance. Then along Y we need to walk Y1 distance, and we can approach the point M. So X1, Y1, Z1. So in combine, we can say the location is X1, Y1, Z1. Now let's think this is not Y, this is Y dash. So this Y1 must have negative sign. Okay. Even though it is looking like y1, but this will be like minus y, minus y, or minus some 3, 4, something like that. It will be some negative sign. It will have the negative sign. Okay. So that's why we can locate this point P. Now, this is all about, we have talked about the case when the position is on the xy plane. Now, suppose someone saying that, no, I don't want to project this point, just take a position of the point P on the xy plane. I want to take a position on the yz plane. Suppose. So take the position on the yz plane. Now we are at the point, suppose this is M dash. Now from here origin, we can approach this M dash. How? Because that is in coordinate geometry. We know about X, Y, so we obviously know about Y. So we walk along this Y dash the distance, and then Z along Z the distance. So ultimately we get this much Y1, this much X1, then this much Z1, and then this much X1. And we ultimately approach the point P. Okay? Okay. Now think like this, that okay. So next question comes, that why now if I go along this line, suppose I am walking like this, first this much distance, then this much distance, sorry, first this much distance, then this much distance, and then going to much distance. So let's draw the point back there. Sorry. Okay. So suppose I am walking along this yellow path, or I am walking along the black path, depending upon my mind, or I can walk along this red path, or we can walk along this green path also, or you can walk along another path, say different color with this magenta color. Okay, or you can walk along different way. That is, suppose this color, suppose this path, this path. So along which path I go to this point P, I will ultimately go to the point P, and in each case, either it is black, blue, green, yellow, magenta, red, whichever path I choose, the ultimate location of the point P will remain same, because along which direction you will walk, you need to cover fixed distance. Like if you want to, you have to go x1 distance along x, y1 distance along y, z1 distance along z. So there will be no change. Even though you can see that here we have obtained kind of planes parallel to YZ plane passing to the point P. This is another plane parallel to XZ plane passing to the point P. Similarly, this is another plane passing through P parallel to XY plane. Okay, so this is also a approach that you can draw a perpendicular plane parallel to the coordinate planes passing to the point P, and accordingly you can find the location of the point P. That is also another approach. But here also you can see that along which along which direction you walk first and second or third, ultimately you will approach P point, and the distance covered along each direction, each coordinate axis direction will be same. Like you can say this magenta distance or this green distance or this blue black or this red, all the length will be same. Even though their positions are not same, their length will be same. Similar for this yellow, this magenta, red, this cyan, this black or green. All cases the length will be remain same. That's why along which plane or along which coordinate we are going to, or which plane we are taking projection, that doesn't matter. The matter will be that the point location of the point will always be same in which along which you walk to that point. So thus we can find the coordinate of the point P, and depending upon the sign of the coordinate, we can clearly say that which is in the which coordinate. Now suppose we have given a coordinate like this. So suppose they have given some x1, sorry, x2, y2, z, and they say that locate this point in the coordinate plane. So coordinate space, three-dimensional coordinate space. The given point is x2, y2, z. For that, what we will do? First, draw the coordinate axis. Suppose that these all are positive, all are sign positive. So I am drawing in the positive axis. Depending upon the sign, you can choose the appropriate coordinate. Please draw. Okay. Now walk x2 distance along x, then y2 distance along y, y2 distance along y, and z2 distance along z. Ultimately, we approach this point as like here. We approach this point P. Okay, and this point is coordinate h2. This point is coordinate h2, y2. Sorry, z2. Thus, given a coordinate, we can find the location of the point in the coordinate, in the 3D coordinate. Depending upon the sign of the coordinate points, you can choose the which object with this point will be like or like. So let's do one example. This question is okay. So suppose I have a figure x, y, sorry, 0, say y dash z, and I can draw a perpendicular box like this. Parallelepiped, you can say parallel things. The point P lies here, and the location of the point P is given that 2, 4, 2, x is 2, minus 4, 5. Okay, and suppose a point is F here. So the coordinate of the point F we need to find. So what is the question? The question is that they are given with the x, y, z plane. There is x, y dash z plane, and there is a parallelepiped, rectangular parallelepiped is there. Now they have given one coordinate of the point, that is 2, minus 4, 5, and we need to find the coordinate of the point F, or you can say coordinate of the point M. Both we need to find. Okay, how we can find? So to approach this point 2, minus 4, 5, we have to walk along this line. We have to walk 2 distance along x, then 4 distance along minus y direction, and then 5 distance along this z direction. Now this M point is lying on the xy plane only, so no need to be worried about it. Okay, so how we can approach this point M? So only we need to follow the Euler path. So first 2 distance along x and minus 4 distance along y. So the coordinate of the point M will be 2 minus 4. We haven't moved along z axis, so this will be 0. Similarly, what about the point F, coordinate of the point F? So we have moved along this point, this one, then this. This is another way, right? So what is the way? First move two distance along x, then minus four distance is four distance along minus y, then again two distance along along what? Negative x. That is, we are not going along x. This is very important. First, going along long distance, again taking a back along this direction. So we are not traveling this distance. This distance is not nullified. Like what? First, we have obtained 2, then again minus 5 minus 2 because here from here we are moving along negative x axis. Along in direction. It is not like I am on the positive x axis or negative axis, not like that. We are going along on the direction. So the sign represents the direction. The sign represents direction. So 2 minus 2 minus 4 0. So that will be ultimately the coordinate will be 0 minus 4 0. Now this is a little bit difficult. So what will be the easy way out? The easy way out will be just think. Let's just move with your lines. Okay. Suppose we have this green line from origin. This is your origin. I am not following the yellow. I am following the green first here. Along y dash, I am covering my 4 distance. Okay, that is minus 4 because the sign or direction of the y is negative. Then I can approach P by this path, right? But I don't need to go along this in this much. Just we need to go up to this. So what is the coordinate of the point F? The coordinate of the point F will be no movement along x, so 0. Along 4, it will be along y it is minus 4. And z, along z it will be 0. So this is the coordinate of the point F. Okay. So thus, depending upon a given point, one can identify the location of the other point. And here must note that what about the coordinate of the point 0? Like origin. What is the coordinate of this point? So to approach this point origin, one need to move 0 along x axis, 0 along y axis, and 0 along z. So the coordinate of the point origin will be 0, 0, 1, 0. So this will be the coordinate of the point 0 or origin. Now, suppose if a point lies on either axis, then its coordinate will be x00 or 0y0 or 00z. So this will be the coordinate of the point lying on the x-axis, y-axis, or z-axis. This coordinate will be for x-axis points on the x-axis. This coordinates for the points on the y-axis. This coordinates for the points on the z-axis. Okay. Similarly, lies on either plane, the either xy plane or yz plane or xz plane, then and its coordinate will be x comma y comma 0. If the points are on lying on the xy plane, or 0 comma y comma z if that is on the yz plane, or x comma 0 comma z if it is on the xz. Now we can see clearly that if x equal to 0, y equal to 0, z equal to 0, then all these coordinates will be 0. That is, it is clearly from this. Here from we can see that the origin 0, 0, 0 lies on the x-axis, y-axis, z-axis, xy plane, yz plane, and xz. That is, this origin will be the position of the coordinate axis as well as the coordinate plane. Okay, and note that another thing. Note that intersection of xy plane and yz plane gives the y-axis with the y-axis. Similarly, cut and paste. Second is intersection of xy plane and xz plane gives the x axis, and the third one will be third one will xz plane, and yz plane gives the z. Okay, so intersection of xy plane and yz plane gives the y axis. Intersection of xy plane and xz plane gives the x axis, and intersection of xz plane and yz plane gives the z axis. So this you can clearly see from the figure, this figure only. Just try to understand that yz plane, that is this one, this is our yz plane, and this is our xy plane, right? So the intention will give us the x, the y axis. Similarly, others you can verify from the figure. But this will be a little bit difficult to understand because if you are learning the first time, so you need to visualize this all the figures in 3D. Like you are put it in the box, and for better understanding, you can think of the corner of your room. Just consider any corner of your room and think the floor of your room like XY plane, and the wall or the corner along the ceiling you can think of as the Z axis. Okay, so the floor, that is wherever this floor is, like floor corners, and you can think of as x axis and y axis, and the corner along the ceiling or going to the ceiling you can think of as a Z axis, And you can think all the things whatever I've discussed today by this real life example. Okay. So by this perspective, you can say this floor will be called XY plane, and the other two walls will be considered as YZ and XZ. Okay, other two walls are called will be YZ plane or XZ plane, and the floor will be called XY plane. Now you can think that these planes are intersecting at x-axis and y-axis and z-axis. How it will look like? Now, how we obtain all these things? And if you are talking, in the beginning of this class, I have talked about a bulb hanging from the ceiling. Now you can think that how you can measure the the location of the lower tip of the bulb hanging from the ceiling using the corner as a origin, the corner of the whole room as the origin. Now, which corner you want to assume as the origin, that is up to you. And depending upon the origin, the length will be changed or the coordinate will be changed. But whenever you fix the origin, along which direction you walk, the location or the coordinate of the point will not change. So, depending upon the location of the origin, the coordinate of the point may change in real life. But whenever the origin is fixed, or you can have a universal origin, then the location of that point will not change along which direction you walk in. Like you may walk first along X, along after that you walk along this Y and Z, depending upon you, but the coordinate of the point will not gonna be changed. So try to understand this all things from the viewpoint of a room, and you can clearly see that in the room you will only have the positive x-axis or z-axis, because other directions are difficult to think. But you can think also like your negative height is nothing but the uh, downstairs room. Like if you are staying in the upper stair, the downstairs room is will be considered as the negative z-axis. Similarly, negative x-axis will can be considered as the next room. Similarly, negative y-axis can be considered as the next room. So you can think of 8 rooms, 4 rooms on the upper stair, 4 rooms in the lower stair, and think of this all the geometrical viewpoint from there and understand the things from that viewpoint. Then it will be much more clear. And origin will be the common point of all these 8 rooms, like upper 4 room, lower 4 room, and at one point will be there, which will be shared by all these 8 rooms. And you can think that origin, and you can look at any point of these 8 rooms using that origin, depending upon the sign of the points of the coordinates. So let's stop at this point. Next day we will find how we can find the distance in the 3D plane or 3D coordinate, distance of 2 points. Or you can also will measure the distance of a point from the origin. How we can measure? So let's stop here.